Hi, I just wanted to respond to the query that you sent to me about your viscoelastic problem modeling in Abacus, and you wanted to use forces instead of displacement in that. And I've just picked up one of my models. This is basically a voided UD composite simulation model. I've already used my PBC 2D gen code to impose periodic boundary condition on it, so you could see it here. And towards the end of that, you could see if you look at the boundary condition section, so it's basically running with a displacement. So there's essentially I'm applying displacement on the model, so really around here. So but what you want to do is that you want to apply force. So the way I will go about doing this is, if you already have an existing model that has PBC implemented with displacement, you probably just need to import that model in ABAC. So let's do that. So file import, and you want to import it as a model, and then you put the link where the file is and change it to IMP. So that's the file. So clearly we'll bring it into Abacus, but it will be in the form of just, a file, a meshed model. And then if you go to the displacement section, so this displacement are basically conditions on the four corner nodes of what you want to use. The number 5 one seems to be always the displacement. So this is essentially the displacement model. So applying a 10 unit displacement at this point on this voided UD composite model. However, we don't want that. So what we're going to do is that we're going to so I'm going to suppress that, because clearly this is not what you want to do. You rather want to replace those with forces. So I'm going to then apply a concentrated force. I'll just call it concentrated force. I'll still use the same step that I've been using before. Switch to concentrated and then continue. Now I need to select that location. If you want somewhere else, then of course you would go ahead and do that. So now I will just put a number here, but then again, you've got to do your calculations to make sure you understand what force is equivalent to the displacement that you want to apply. So this basically is 3000 and everything remains the same, so clearly that force is there. And then you just go ahead and run the model and see what happens. So so job tensile sim based on concentration force, so something like that. So this is our job, and we'll just go and quickly run that, and then we'll look at the result. So I'll submit that. And the reason why this is so that it doesn't matter whether you apply a force, a temperature, or displacement, because the domain is described as PBC aware, because I've already implemented periodic boundary condition on all the edges, all the internal nodes. So these corner nodes, these 4 nodes, are essentially places for you to apply whatever loading you want. So it could be displacement, it could be force, it could be moment, whatever it is. But the system is periodically boundary condition aware, and this is why it will work. So you still get the same kind of response as if you would have gotten if you are dealing with displacement. So let's look at results. So, and you get a result that is periodic. So just to kind of exaggerate this a little bit more, just to make sure, so okay, let's probably make it maybe 10 times as big. Okay, so that's probably too much. So yeah, so you get something that probably looks like we'll expect a periodic boundary condition problem, and then you could look at the way the simulation runs. So it definitely shows you that it's still doing the same thing, whether it's displacement. The same thing hopefully should apply if you do a temperature, a velocity, and all that. Because, and this is what is excellent about the way that I try to do this, because I'm applying a load on a corner node and it's generating the result. It's applying the loading. But the key thing is that these internal nodes, both top, bottom, one, have been implemented with PBC. All right, thank you.